but I'll be very clear with the date and exactly what you do. But I'll finalize it just during lunch and post it. I really wasn't sure how far I would get today, but I'm guessing it's going to be a worksheet, most likely with answers provided to you. That I'll just email it to you. You can print it off yourself or work it on a sheet of paper while you look at it on the screen. But I think the worksheet I've chosen actually then gives you the answer so you can check and see how you're doing. And then you might have a brief Delta Math on this other topic. So we'll see how far I get before we do some presentations. Okay, so let's say I have 5. Let's say this works. It was working just a second ago. There we go. What about 5x plus 2 over x minus 7 plus 3? Let's make it minus. Let's go in and start off with things we've got to worry about. Minus signs should always be like caution signs to you, or stop signs even, like stop and think. Don't forget that that whole thing is subtracted, okay? Over minus signs I've got to worry about, so you've got to worry about them. You've got to make sure you handle them correctly. X plus 3. Sorry, it's slow. All right, from the very beginning, as an honors student, you're aware of the domain based on what you just studied. These are the kind of problems where, when you're actually solving an equation, you can get those extraneous roots that used to maybe drive you crazy. Like, this is ridiculous. I used to think it was ridiculous. I remember Miss Hodge, my teacher, calling them extraneous roots, and it sounded so funny. And but they would aggravate me. I would think, how in the world did I carefully work the algebra problem completely correct and get an answer that doesn't work? It's because once you take that first algebra step, you're lifting the restrictions. Okay? A lot of times, if it's a square root, don't be square. The square root was restricting it to only positives and zeros. But once you square both sides, I don't know if you've ever thought about that. Once you do your first algebra step, you've changed the problem. And it lets people in that shouldn't be there. Okay? So once I start to work on this problem, if it had an equals, right now it's not an equation, but if it was an equation like equals 5, wouldn't I probably multiply both sides and get rid of the denominators, blah, blah, blah. And once I do that, I've changed the problem. Do y'all see, based on your recent knowledge and knowledge from Algebra 2, I can never have 7 and negative 3 as an answer. What I want to train you to do as a really good mathematician is be aware of your domain on the front end, because a lot of us forget to ever check it on the back end. It makes your life so much easier, just have a really big picture awareness. Do y'all see what I mean? I was a whole, an asymptote, whatever, but I cannot allow 3 and I can't allow negative 3 and 7 into my answer. Okay, after all of that was rewind. I'm not actually getting an answer right now. I'm just trying to subtract expressions. So I'm not trying to solve for x. Do you see this does not have an equal something? This is not an equation. It's called an expression. All right, so what we would do is get a common denominator. All right, so what's our common denominator? Thank you. Are y'all okay with that? Just take your time. So Katie and I would multiply this one with, use parentheses. What did that say, 5x plus 2? Okay. What do you need to multiply the front one by? X plus 3. And the back one? X minus 7. All right, why is that legal in algebra? Why can't I just up and do that?
Because what you're doing to the top and what you're doing to the bottom is the same. So it's
not really changing the number, am I? I'm multiplying by 1, okay? All right, so now I have my common denominator, and if we could read this horrible writing, we could distribute. So that gives me 5x squared plus 2x plus 15x minus, be really careful here, 3x squared. What's this going to be? Plus 21x. Do y'all see what I mean? I don't know if you can read the writing anymore. I think that was 3x times x minus 7. But do you see that red minus sign? I've got to keep it going. I've got to say minus this, minus that, minus this. Girls, you won't distribute the minus sign to the top and the bottom. Hang on, I may have made a mistake, and I'll go back, because that's what it looks like. People's faces are looking like I made a mistake. But if I have negative 3 over 4, that doesn't mean negative 3 over negative 4, does it? It means you negative 3. Couldn't you put it on the top or the bottom or out in front? But please don't negate the top and the bottom, because then you haven't done what you're supposed to do. What'd I mess up?
Isn't there supposed to be a 6? Yeah, but
Oh, I thought my 2 was a 7. Thanks. I'm going to write a little bit neater on the next problem. Sorry. Thank you. So that's why all the puzzles. I thought people were giving me puzzling looks because of my sign, but it's because of my number. Oh, wait. No, this is a 7.
no, like no, 5x squared plus 2x plus 15x plus 6 minus 3x squared.
I'm going to start over.
Okay.
I can't read my own writing. I'm not sure how I expect you to. Thank you. All right, start over. So this is 5x squared. That's probably plus 2x, 15x, and I need a 6. Now I'm all worried about the negative sign, so be careful that you do the easy stuff right. I have minus 3x squared, and that was a 21, minus a negative is plus 21x, over x plus 3, x minus 7. All right, so on the top I have 2x squared, so I added these. How many x's do I have? 17 and 21? 38? 38x, and do I only have one number?
Yeah.
6. All right, now, you don't have to multiply out the x minus 3, x plus 3 times x minus 7. You'll notice that there's some things I multiply out and some things I don't. And at first it will be kind of confusing, like, are you just doing it by chance, or how are you going to know to pick and choose, like I know to pick and choose? I bet some of you can tell me why I haven't multiplied that out yet.
Because then you know which ones aren't possible.
You can clearly see now where the asymptotes are. You had to graph this expression. What else? There's another reason. You'll see all year that I do this.
Oh, well, I don't know, but
Go ahead.
this is what we're back to, but like if you factor the top.
Yeah,
And
you
then
don't want to
you
have to
cross that.
refactor the bottom. Do y'all see what, like, I'm wondering if something's going to cancel. I had to do all that addition and subtraction on the top until I got this happening to be quadratic, a polynomial. But I would not give you full credit for this if it still simplifies, which I just made it off the top of my head. I don't know yet, okay? But if it still simplifies, you see it's best for me not to multiply that stuff out, just to factor it in. There'll be times during the year I guide you. I'll kind of let you know, like, when I decide to multiply things out or not. Honestly, I don't care if you ever multiply the bottom out or not. It's not going to change the problem, right? So you can just leave it if you want to. If you're trying to check an answer, it's easy enough to check. But I would, that's what I was looking for. All right, first rule of factoring is take out what's in common, because if there is something in common, it makes my life a lot easier. I'd much rather factor with an x squared than a 2x squared. You probably would also. Probably. I can already tell it's going to be one of those days. It's already been one of those days. I didn't sleep any last night because of how bad my foot hurts. Because it looks really horrible. Thank goodness there's a Band-Aid on the swollen part that you can't see up close because it's really gross. But anyway, I think I get bitten by a spider. And the infection's like so deep in my foot that, so I went to the doctor this morning, and now I'm making all these mistakes. Because my foot hurts. Not really, I'm just making lots of mistakes. So now, Katie, ever done something else wrong? Okay, I don't think it's going to pass. All right. Now, one thing that I'm not a big fan of the quadratic formula. It's shocking. Okay, that's shocking, I know. I don't really care because I might not. So often I don't get a quadratic. I get like something with an x cubed on the top. It just doesn't do me that much good. I don't want you launching into the quadratic formula because so often you can just use your calculator to find your zeros. Because when you do the quadratic formula, what in the world are you going to do with 5 plus or minus square root of 17 over 8? You're going to want a decimal anyway. So that's for another day probably. But one thing I do use that I do love about the quadratic formula, and also may be shocking, is the discriminant. I use b squared minus 4ac a lot, okay? Factoring's not all that it's cracked up to be, but you can't move forward without it. You've got to be super good at it, and notice that I'll factor really fast, hopefully correctly most of the time. But I'll do a quick double. I can tell that's not going to factor, but if I don't know, I'm not going to sit around and do all my little techniques for factoring. If I know ahead of time, it's not going to factor anyway. When you like to know ahead of time. So if you do b squared minus 4ac, where is that in the quadratic formula? Under the what? So if you do b squared minus 4ac and you get a negative, don't try to factor it. It's not going to factor. Or if you don't get a perfect square. What if b squared minus 4ac is 81? That means you could have factored and gotten integers. If you have the square root of 83, that means you're not going to be able to factor. It doesn't mean it doesn't have any answers. It just means they're not going to be any that you thought of. So you need your calculator or the quadratic formula. All right, so that one's simplified. Okay, so you'll have some of those. I don't think you really need me for that. You just need to practice it because no one slows down through all of this. And you'll eventually be doing this very soon with me with words like sine and cosine in it, and logarithms and exponents. And I mean, so get used to it with polynomials because it's the same thing when you hit other functions. So I expect you to be good at it, okay? All right, so be careful with your adding and subtracting. Let me check one thing before I do. I don't know that you need a lot more examples of that. And like I said, I'll provide you with an answer sheet. So you'll have adding and subtracting. Let me do a little bit harder one. Okay, so Elena, should I go back?
Can I go to the back?
Oh, yeah. All right, so I'm doing this one is x plus 2 over 2x squared plus 13x plus 20. This one has a minus sign I have to be careful with. That's 20. Let's see. Okay, I think I made that up correctly. All right, so we're doing this one. I think before we find the common denominator, we probably want to factor. The reason I want to factor is if it has a factor in common, I don't have to multiply by quite as much. Right now, they don't look anything alike, and I need all of that, okay? So I'm going to factor this one. First rule of factoring is take out what's in common, but there's nothing in common. So I'm going to just do trial and error, which is actually what I do. I don't use any cutesy little technique. I'm good at doing trial and error. You should be too, okay? So I'm thinking of factors of 20. The first thing that comes to mind is 5 and 4. And what I thought about is if I put 4 here and 5 here, it gives me 14. I can see it in my head. I don't know if I put 4 here, that gives me 4x. And if I put 5 here, it gives me 10x. So I switched them and it works, and on and on. So you just trial and error really fast. Now, a few of you with a calculator, though, I want you to do this for me. Do b squared minus 4ac. I might can do it. 169 minus 160. Is that right? 8 times 20. And I get 9, which means I should factor it, right? Because under the quadratic formula, under the square root, I get a perfect square. That means I should factor it. All right, this one, everybody knows, is x plus 4, difference of squares, x minus 4. Oh, and who is it that's got to keep reminding me to one day show you the cubes, okay? Just don't let me forget. All right, so what is really my common denominator? What all do I need in the denominator?
2x plus 5.
I need a 2x plus 5. Do you see why factoring helped a little bit? Because I only needed 3 things, not 4. So what do you need to multiply this one by? All right, I'll do it in yellow. What does it need? X minus 4. So this needs x minus 4 times x minus 4. Guess I should do it in red. And what does this one need?
2x plus
2x plus 5 and 2x plus 5. So you see, you may be kind of surprised at how I'm working. It's a little bit efficient. I'm just sort of writing notes to self. I'm not rewriting the whole problem. It's up to you. All right, on the top, that's going to give me x squared plus 2x minus 4x. So that's minus 2x. Y'all check me with, apparently this is a mistake day for me. This is minus 2x squared minus 5x minus 6x minus 15. Do you see how I'm distributing the scary minus sign? Hopefully. And aren't you glad I don't make you multiply at the bottom? And if you did, you wouldn't want to then have to refactor it to see if something cancels. Do y'all see I'm just saying hold out? Just wait. Okay? I think I have a negative x squared. Did anybody get my x's yet? Minus 13x. Minus 13x minus 23 over 2x plus 5, x plus 4, x minus 4. That says x plus 4x minus 4 down there. If I do b squared minus 4ac, I also teach you like good logical, critical thinking techniques. There's no point in me trying to factor it because what's minus, what's 3 negatives make? Oh, you know what? It might. I thought that one was going to definitely end up in the negatives. Like if you see something like 20 minus 83, there's no point going on because you can have a negative in the square root. But 4 times 23 is not too big. So let me keep going. So this gives me 169 minus what?
92.
What is that?
72.
76?
77.
7. Oh, 9 minus 2 is 7. Thanks. I'd tell you something scary and kind of funny. Might as well tell you because you'll notice. AP Calculus BC is easier for me than adding and subtracting. I just something in my brain. The harder it is, the better I am at it. I'm not really good at subtracting. I'm not really good at adding. Sorry, it's just like I'm too mundane or something wrong with my brain. Anyway, I can't square it at 77, and so you just leave it like that. Be aware of it where it's undefined. One thing I think Katie said, maybe somebody before you said one of the main reasons I want it factored is in case it cancels. But also, factored form makes me real aware of where this does not exist. Those would all be vertical asymptotes. Most likely, none of them would make the top 0 because if it did, I would have been able to factor the top into one of these factors. Just to kind of merge it with what you've done. Okay? So you'll be adding and subtracting rational functions. All right, on a worksheet that I'll post for you. Now, last thing, and we expect you to be, you can't imagine how important that is. If you walk in and the calculus class has just been in here, it's like the board's covered with being able to, after you do the calculus, then you've got to be able to do this stuff, especially in derivatives. So, moving on. If I had a pig, that's who it would be. Okay, we're also going to be doing complex fractions. Like, in AP Calculus, I don't even care, I'll write it in and I don't even care if they reduce something like 16 divided by 8. You know, in math, they've already got the right answer. In fact, sometimes I don't want to reduce it. Oh, look.
Those are my pictures, guys.
Anyway, sometimes we don't reduce because we really want to give an indication that 16 people voted for this and 8 people voted for that. You might say, you know, twice as many voted, but if it was 4 people for this and 2 for that, you might want to know if you were hoping it was going to be your sweatshirt color, as opposed to, you know, 40 people voted this way and 20 people voted. Do you see how it gives a different indication? Be that as it may. You are not allowed to leave what's called a complex fraction. That means you have a fraction in a fraction. Okay? The reason for that is it's so incredibly misleading. Doesn't 4 divided divided by 1/2 feels small. But it's not. What is it? It's 8. It can be so misleading. And if you don't leave a decimal as a fraction, okay? I'm sorry. You can do that. Don't leave a decimal in a fraction. Make a decision. Don't give me 0.3 divided by 1/5. Do not do that. Do not give me 0.3 over 5. Make a decision. Give me a decimal or a fraction, because right now you don't probably have a sense of what 0.3 over 5 is. This would be like if I had 4 candy bars and we were going to try to share it. Wouldn't I start breaking them in half and then I would have 8 pieces?
Yeah.
Okay. So instead of dividing by a fraction, you multiply by the reciprocal, or you have some cute little other saying that I don't know. So anyway, but we're going to have things like this. Okay? That's a complex fraction. I don't think you're going to have any trouble with this. You did it in Algebra 1.
What's the number on the two?
This is a 2. This is a 7. And I'm going to multiply by x minus 1 over 7. Then before you start multiplying, you're going to check and see if anything cancels. Do y'all see what I mean? Wouldn't that make sense right now to see if anything cancels? So be aware. Nothing cancels. And so I'd probably write it like this. I'd probably just write it 7 times x plus 2 over, I'd probably multiply the top out, but I might not. 3x squared. It kind of depends on what I'm doing. What is that, minus 4x plus 1? It's certainly not going to be difficult to write the bottom as 7x plus 14. I'm just in the habit of, I usually don't multiply the bottom out because I want to be able to look at it for for asymptotes and everything, okay? All right, now I'm going to do this problem behind me on the board. Okay, so let's see. I think we're now transferring to chickens. Okay. When? Oh, okay. I'm sorry I missed it. Okay, next class. Thank you. Send me pictures. What color are you going?
Also, I said, Harry Styles pictures. Oh, no.
Did you do it a long time ago?
No.
Oh, okay. Because I have Harry Styles slides. Okay, thank you. Great. We've got slides coming your way. All right. Anyway, look at this. Suppose I have. What color is that?
No, you're yellow or she meant, no, it's just, you changed it. Yes. Cool.
What, you don't like this one?
No, I
Okay, anyway. Suppose you have x plus, well, I'll do the one behind me. Or am I? I know. I'm going to get rid of it. I was just teasing her. Is that bothering you, or should I leave it?
A little bit.
So now you're combining the two things. We're adding rational functions, and one of them is I think it's a 2. 2. We'll call it a 2. Okay, so now we've got to fix up the complex fraction before we ever add them together, okay? So I think most of you would make this 1 over x minus 1. And this is going to be 2 times x minus 1 over x. So I just did that sort of in my head, sort of kind of where I just multiplied by the reciprocal. Let me know if you're not okay with that. All right, what's my common denominator? X times x minus 1. So what does this one need? X. And this one needs? All right, so this is going to become 2 times x squared minus 1. Are y'all okay with that difference of squares right here? So I get 2x squared plus x minus 2 over x times x minus 1. Will that factor b squared minus 4ac? Did that give me 17? Did I do that right? I don't think the top will factor. You all okay with that? Okay, so don't you like b squared minus 4ac?
It's minus. Oh. And I just got near the top. Not x, not plus x, so minus 2. But it's also negative.
All right, I have a 2x squared. Then I have this x. And that would be minus 2?
Minus 2. But it's still minus x. Because, like, when you. No.
Let me do the top slower. This is x plus 2x squared minus 2. And I just rearranged it and did it all at once.
You just factored, you just did that.
I probably should have slowed down on that one. So if I multiply the top out here,
No, I understand. I thought you were calling the x minus 1
is everybody okay so far now? Okay, Elena?
When you did when you factored the 2x whatever it was before, it's 2 times x minus 1, and then you multiply them by x minus 1 again, can't you just cancel out the x minus 1 from x minus 1?
Then you go back to where you started from and you wouldn't have a common denominator.
Okay.
I'll put that in there.
Okay.
So, I mean, you could and then start over again. Great question, though. I think I've simplified it, but let me take more comments. Maybe not. Rebecca?
Is it the top one 2x minus 1 squared? Like for the second part? Right there? And then that
This
would-
part?
Yeah. So wouldn't
Yeah,
that
that's what I'm
equal
saying. Wouldn't it be x?
2 negative 4x in addition to all that?
Yeah.
Because it's not x minus
It'd
1,
be 2
x
times
plus 1.
x
It's just
squared
2.
minus 2x plus 1.
So it's like,
Thank you. I was treating it like a difference of squares. I see what you mean. I was treating it like x minus 1, x plus 1. The good news is I usually do all of these horrible mistakes all packed into one day. Like I just have a really bad day. So don't panic. Thank you, Katie and Rebecca and everybody else that probably noticed that. I treated this like a difference of squares for some reason. X plus 2 times x squared minus 2x plus 1. It took me a while to hear what you were saying. Over x times x minus 1. Everything okay now? So now I'm going to try to do it really fast. 2x squared minus 4x. So that'll be minus 3x. Plus 2 over x times x minus 1. B squared minus 4ac. Doesn't look like it'll factor. Provided that this one's correct.
Is that the one we were doing?
It is the one we're doing. But it's got that x minus 1 in it every time I do it.
That's true. Why don't you put chickens on the wall?
Morgan gave me the chickens.
The chickens?
Yeah, I got to tell you my chicken story later. I have 2 stories to tell you.
Ducks or chickens?
I
Ducks.
I almost have the time to tell everybody my chicken story, but I don't think y'all know me well enough for chicken stories. So. Okay, so sorry about the presentations, but you'll do it before the test, so your group gets to still think about it and see me. Bella, for now, you'll just watch. Okay. They did like rational functions for presentations. Okay. Homework will be posted in the next couple of minutes. Okay.